Okay, students, a question is to construct a DFSM to accept strings of A's and B's having even number of A's and even number of B's. Second is even number of A's and odd number of B's. Third one will consider odd number of A's and even number of B's. Fourth one, odd number of A's and odd number of B's. So first we'll try to find the solution for this. First one, that is, which is the first question? First is even number of A's, even number of A's and even number of B's. Even number of A's and even number of B's. For that purpose, here the given language can be written as, to solve this problem, the language can be written as L is equal to number of A's in string W mod 2 is equal to 0 and number of B's in string W mod 2 is equal to 0. So here the given language we are going to write like this. In the above language we have both number of A's in string W and number of B's in string W. Number of B's in string W mod 2 is equal to 0. So first what we'll do, we'll try to construct two different machines. We call it as, I'll call this as machine 1 and this as machine 2. On the input on with respect to the number of A's in string W mod 2 is equal to 0 and number of B's in string W another with the number of B's in string W mod 2 is equal to 0. So first I'll construct the machine M1, that is number of A's in string W mod 2 is equal to 0. Number of A's in string W mod 2 is equal to 0. So here, how do we construct this one? So that is nothing but it should accept a even number of A's. So 0, accept 1, reject the string non-final state. Again 2 is, it becomes an even, it accepts. This is our state Q0, this is our state Q1. So first we have constructed a machine which accepts a number of A's in string W mod 2 is equal to 0. That is, we'll write it as machine Q1. That is, we have the states Q1 is equal to, what all states we have? We have Q0 and Q1. If I go for the another machine, that is M2, what it should accept? The machine M2 should accept number of base in string W mod 2 is equal to 0. That is, it should accept the even number of B's. So here I'll name it as P0, P1. This is odd number of B's. Reject, go to a non-final state. Even number of B's, accept, go to a final state. So the states of this one are Q2 is equal to, we have the states P0, P1. Now, according to the given problem, it has to accept both the number of A's and number of B's should be even. So for that purpose, we need to take the cross product of these two. That is, Q is equal to Q1, Q2. That is the cross product of these two. We'll take it as Q is equal to Q1, Q is equal to Q1, Q2. What we are doing here, for even number of A's and even number of B's, we are taking the cross product of Q1 and Q2. That is, we have Q1 is equal to Q1 comma Q2, which is equal to, we need to take Q0 P0, cross product of all the states, Q0 P0, next Q0 P1, Q0 P1, next Q1 P0, Next, next Q1 P1. So we have taken the cross product of all the states. Next, once the cross product is taken, what is the next step? We need to find the transitions here. So that is, first we'll take the first state on all the inputs. That is delta, delta. First is Q naught P naught on A input. So we need to check Q naught P naught on A where it is going. So here Q naught on A where it is taking or going Q naught on A, it is going to Q1. First we need to write like this, that is delta Q naught on A union delta P naught on A. P naught on A. So if we check here, Q naught on A where it is going, Q naught on A it is going to Q1. We'll write it as Q1. So P naught on A is not defined, so we'll write it as union P naught itself. So we'll get the states as Q1 P naught. We got the states as Q1 P naught. Next, we'll go to the next one. What is the next? Next we need to think, next state is Q naught P1. Same fashion, delta Q naught P1, sorry, Q naught P naught on B input also we'll check. Q naught P naught on both the inputs we need to check. Q naught P naught on B, we'll get it as delta Q naught on B union delta P naught on B. That is equal to. Whether Q naught on B is defined? No, Q naught on B is not defined. So what we'll do? We'll keep a Q naught as it is, union P naught on B is P1. So we'll get it as Q naught P1. So we got the states as Q naught P1. Next, similarly, we have to go for the next one, Q naught P1. That is delta Q naught P1 on A. Similar to that, what we have to do? Q naught on A, union P naught on A. Q naught on A, where it is going to the state Q1. So we'll write it as Q1. P1 on A is not defined. So what we'll do? We'll keep P1 as it is. So we'll get it as Q1 P1. Q1 P1. Next, same thing. Q naught P1 on B input. That is delta Q naught P1 on B. So Q naught on B is not defined. Whether Q naught on B is defined, it's not defined. So what we have to do? We have to keep Q naught as it is, union P1 on B. P1 on B, where it is going? It is going to the state P naught. So we'll write it as P naught. So we'll get it as Q naught. Q naught on B is not defined. Q naught as it is. Q naught on B. P1 on B is P naught. So we'll get the states as Q naught P naught. We'll get the states as Q naught P naught. Next, which is the next state? Next is Q1 P naught. We need to write the for Q1 P naught. How do we write now Q1 P naught? That is same thing. Delta Q1 P naught on A. So Q1 on A, where it is going? It is going to Q naught. Union P naught on A is not defined. Keep P naught as it is. So we'll get the states as Q naught P naught. So next, which is the next one? Next we have Q1 P1 we have done. Q naught P naught is done. Q naught P1 is done. Q1 P naught on A is done. Next we'll do Q1 P naught on B. That is delta Q1 P naught on B. Okay, Q1 P naught on B. Check it out where it is going. Q1 P naught on B. Q1 on B, where it is going? Q1 on B it is not defined, so it is going to be Q1 only. Union, what is the next one? P naught on B. P naught on B where it is going? P naught on B it is going to P1. So we'll get it as Q1 P1. So the next we are done with Q naught P naught, Q1 P1. The next Q1 P naught on AB is done. Next left out is Q1 P1. Q1 P1 on both A and B we need to input, we need to check. So we'll write here delta Q1 P1 on A has to be found and delta Q1 P1 on B need to be found. Q1 on A where it is going? Q1 on A it is going to Q naught. Union P1 on A it is not defined. We'll write it as P1 only. So we'll get the states as Q naught P1. Then next is Q1 P1 on B input. Q1 on B is defined. Whether Q1 on B is defined? No. So we have Q1 as usual. Union P1 on B is P naught. So we are getting the states as Q1 P naught. So now if we check here, we have taken the cross product. We have got the states as Q naught P naught, Q naught P1, Q naught P naught, Q naught P1, Q1 P naught, Q1 P1. So next for all these states, we have taken the inputs, input alphabets A and B, and we have defined. So we have got all the states. So which all states we have got? Q1 P naught, Q naught P naught. So we have got the states now. All the states, that is Q1 P naught, Q naught P1, Q1 P1, Q naught P naught, Q naught P naught. Then next comes here, we have Q1 P1, Q naught P1, Q1 P naught. So we have got all the states. Totally, if we check here, we got the four states here. So we write all the four states here. One, two, three, four states. So we have got the states as Q naught P naught, Q naught P naught. Next we have got the states as Q naught P1, Q naught P1, Q naught P naught, Q naught P1. Then next is Q1 P naught. Then here comes Q1 P1. So we have got the four states now. After getting the four states, next we'll check the transitions. How do we check the transitions? So here check here. If we go here, we have here Q naught P naught on A. Where it is going? Q naught P naught on A, it is going to Q1 P naught. So Q naught P naught on A, it is going to the state Q naught. It is going to the state Q1 P naught. Sorry, and right here. It is going to the state Q1 P naught. Check here. Q naught P naught on A, it is going to Q1 P naught. Next, Q naught P naught on B, where it is going? Q naught P naught on B, where it is going to, which state it is going? Q naught P naught on B, it is going to Q naught P1. It is going to the state Q naught P1. Q naught P1 on B, it is going. Then next, Q naught P1. If I check the next one, Q naught P1 on A, it is going to Q1 P1. Q naught P1 on A, it is going to Q1 P1. Q naught P naught, Q naught P1 on A, it is going to Q1 P1. On A, it is going to Q1 P1. The next, Q naught P naught, Q naught P naught, sorry, Q naught P1 on B, it is going to Q naught P naught. On B, it is going to Q naught P1. On B, it is going to to Q naught P naught. Then next similar to that, next we have Q1 P naught. If you check here, we have Q1 P naught on A, where it is going Q1 P naught on A, it is going to Q naught P naught. Q1 P naught on A, it is going to Q naught P naught. Then next Q1 P naught on B. Q1 P naught on B, it is going to Q1 P1. The next Q1 P1 on A. Q1 P1 on A, it is going to Q naught P1. Similarly, Q1 P1 on B, it is going to Q1 P naught. Now, for all the states on the inputs, A and B is defined. Now, which is the start state in machine 1? Q naught is the start state. Which is the start state in machine 2? P naught is a start state. So, Q naught, P naught is going to be the start state of our machine. So Q naught is the start state of our machine 1. If you check here, Q naught is the start state of machine 1 and even the P naught is the start state of our machine 1. So when Q naught is the start state of machine 1 and P naught is the start state of a set which consists of Q naught, P naught is going to be the start state of our constructed machine after taking the cross product of both the states. And similarly, the final state also, this is a Q naught is a final state, P naught is a final state, a state which consists of both Q naught and P naught is going to be the final state of our machine. So this is our start state and this is going to be our final state of the machine. So here, why we are taken this as a start state and accepting final state here, Q naught is a start state of machine 1, even the P naught is a start state of machine 1. So we are taking the cross product of both the machines. So the state which consists of both Q naught and P naught is going to be the start state of our machine. So this is a start state. Even Q naught is a start state and P naught is a Q naught is a final state and P naught is a final state in both the machine. A set which consists of a state which consists of Q naught P naught is going to be the final state of a machine which consists of which accepts the even number of A's and even number of B's. Now, similar to that, the next question is to check for the next question we have taken is even number of A's and odd number of B's. So second one is even number of A's and odd number of B's. Second one, even number of A's and odd number of B's. Even number of A's and odd number of B's. See here, it is similar to the our previous problem only. Only the thing is when we say it as a even number of A's and odd number of B's, even number of A's, the machine one will be in the same fashion. That is, it will be same. Even number of A's is, so this is going to be the final state. Q naught, Q1. This will accept even number of A's. To accept the even odd number of B's, what we'll do? The small changes we are going to do is odd number of B's it has to accept. So this is going to accept the odd number of B's. Fine. So odd number of B's. P naught, P1. So all the steps will be the similar one what we have done for the previous problem. Only the difference will get the same set of states. So here we are going to have Q0 P1 Q1. Here it is P0 P1. So we are going to make the transitions in the same fashion. Only the difference lies. So we'll get the same transition diagram here. So we'll get same naught P naught Q naught P1 Q1 P naught Q1 P1. So here same thing we'll get on B inputs. Here it is on A. Here again on B. Same as I said, it is similar to the previous problem. All the transitions will be the same fashion. This one. Yeah. So now start state in both the cases is Q naught P naught. So we'll try to make the start state as Q naught P naught only. Only the changes lies in a final state. If we check here, which is the final state here, Q naught is the final state. Which is the final state here, P1 is the final state. A state which consists of Q naught and P1 is going to be the final state for accepting the even number of A's and odd number of B's. Check here, Q naught P1 is going to be the final state. So Q naught P1 is going to be our final state. Check here. 1B, simple way. 1B, what it is doing? It is going to odd number, it is going to final state. Even number of A's, go here, non-final. Again, go here, final state. If you come in this fashion also, 1, 2 A's, then 3, 1B, then go here, 1A, 1, go here 2, 3 A's we have got, 1 B we have got, fourth A, then it goes to an accepting state, final state. So if you check, if you take any of the input string and check if there are even number of A's and odd number of B's, then the string will be accepted, else the string will be rejected. So similar to that, our next example is, next one, third one I have given it as, which is the third one, which one we have taken it as a third one. Third one is, third question is, odd number of A's and even number of B's. I think you have got an idea. Now in this case, odd number of A's and even number of B's. Odd number of A's and even number of B's. So what we are going to do here, odd number of A's and even number of B's, same fashion here, similar to the things what we have constructed in the previous this thing. So here, odd number of A's is nothing but first machine to accept the odd number of A's. This will accept the odd number of A's, right? Check here, Q0 P1, Q0 P Q1, 1A accept odd number of A's, 2A reject, 3A accept. So it is accepting the odd number of A's. Next, even number of B's. Even number of B's is, this is P naught, P1, 1B, 2B. So even it should accept. So we have constructed two different machines which accepts a even number of A's, odd number of A's and even number of B's. Same similar to that fashion. Take the cross product of this one. We'll get the set of states, define the transitions. So same set of states we'll get, that is Q naught P naught, Q naught P1, Q1 P naught, Q1 P1. That is, we'll write it as Q naught P naught, Q naught P1. Here we'll get it as Q1 P naught, Q1 P1. So we have here, this is A, A, B, B, A, A. Same thing. No need of more expression. Same thing what we have done for the first problem. Similar to that, we'll get all the, when we take the cross product and transitions for both the A and B inputs, we'll get in the similar fashion. Same, which is a start state. Q naught P naught is a start state. We'll make this as a start state, which is a final state here. Here it is Q1. Here it is P naught. Q1 P naught is a final state. We check here, simple way. Check your odd number of A's. 1A accept, 2 reject, 3A accept, even number of B's, 1B reject, to be accept. Check any input string. If the input string is having even odd number of a's and even number of b's, then this machine will accept the string. Else it is going to reject the string. In this last one, fourth one is, which is the fourth question here in this. The fourth question is to odd number of a's and odd number of b's. I think you got an idea how to construct odd number of a's and odd number of b's. Odd number of b's. So odd number of a's and odd number of b's here. Similar to that, construct two different machines which accepts the odd number of a's and odd number of b's. Odd number of a's. This is Q naught, Q1, 1A, 2A. So 1A is an odd number of A. Make this as a final state. Similarly, for odd number of B's, another machine for odd number of B's, here we have B. Here is also B. Here we are getting P naught, P1. So which is going to be the final state here? Q1, sorry, odd number of B's is this one, P1. So 1B final state, 2B non-final. Again, it is going to accept the, what it is going to accept? It is going to accept the even number of odd number of A's and odd number of B's. Similar to our previous example. So same four states. First is Q naught, P naught, Q naught, P1, Q1, P1, Q1, P naught. So here we'll get the same transitions on A, this also on A, this on B, this on B, this on A, this here, B, B. So which is going to the start state. Q naught and P naught are the start state of all the two different machines we are constructed. So Q naught, P naught is going to be the start state, which is going to be the final state. Q1, P1 is going to be the final state. See, check here, odd number, simple way, odd number of A's and odd number of B's. A, 1, B, 1, odd. Again, if you check here, 1, 1. Even, go to non-final state. Odd, come to a final state. This is how it is going to accept this DFSM machine, whatever we have constructed, which will accept the odd number of A's and odd number of B's. I hope it is clear. Fine, students. Is it clear? Huh? Is what all we have done in this example, what all we have constructed. We have constructed four problems. The steps involved in all the four problems are similar. Only in the last bit, what we have done, we have tried to construct same thing. Take first construct one machine, construct the another machine. Once you construct both the machines, we'll get a set of states. Take the cross product of those states. For all those states on input A and B, we need to check where it is going. So based on that, we have constructed the four different machines which accepts a even number of A's and even number of B's, even number of A's and odd number of B's, odd number of A's and even number of B's, odd number of A's and odd number of B's. Okay, student, I hope it is clear. Thank you.